So today we have a cool geometrical problem. The diagram is on the screen with all the given details. Now the question over here is to find the area of the semicircle using the arrangement of this diagram and the given data that area of these quarter circles are 9 and 4. So this is Anmol Mishra and now let us see the solution. How can we solve this problem? So first of all, take a note of this thing, that we have to find the area of the semicircle, and to do so we have to use the arrangement of this diagram and the given data that area of these quarter circles are 9 and 4. This means the area of the semicircle is ultimately related to the area of the quarter circle. So it would be more interesting to see that relation. So I will simply take the area of the bigger quarter circle instead of 9 as a variable capital A, and area of the smaller quarter circle instead of 4 as a variable capital B. And once we will get the required relation, we will simply change A and B as 9 and 4 in order to get the answer to this question. Okay? So now the first step in the solution is to mark the radius of these figures. So I will take the radius of this bigger quarter circle as a variable x, radius of the smaller quarter circle as a variable y, and radius of this semicircle. So for that I will mark the center of this semicircle and label this as the point O. Therefore the distance RO is the radius and I will take it as a variable z. Okay. Now look carefully that this angle over here and that angle over there are 90 degrees because they are the centers of these quarter circles. Okay. Now what I will do is I will simply draw a perpendicular PM to the diameter of this semicircle. This has the 90 degree and I will mark this particular point over there as a variable M. Okay. Now look carefully in this particular quadrilateral. First of all, this angle is 90 degrees by linear pair. Now by angle sum property, that angle is 90 degree. Hence we have a quadrilateral, all the four angles are 90 degree. Therefore it is a rectangle. Now in a rectangle, opposite sides are equal. If this side is having a length x, this side would also have a value x. What can you say about the length of this side? So look carefully that it is the radius of this blue quarter circle, hence it would have a value y. Therefore the length of this line segment would also be equals to y. Okay. Now I will simply draw a yellow line segment from the point P to the point Q. Now what can you say about the length of this particular line segment that we have just drawn? So now in order to get the value of PQ, look in this triangle PMQ. It's a right angle triangle, the point P, M and the point Q. The length of PM is equals to y. The length of MQ is equals to x plus y. Look carefully, x plus y. Okay. And PQ is the hypotenuse. Therefore by Pythagoras theorem, the length of PQ, that is the hypotenuse, would be equals to square root of x plus y, the complete square, plus the y square. Okay, this is the length of PQ. Now again look back to the diagram and this time draw one more line segment joining the point P and R. Okay, so here we have drawn the line segment PR. Now look carefully, we have an angle RPQ inscribed inside a semicircle. Hence by the theorem, this angle over there would be 90 degree. So the triangle is like this way. Okay. This is the point R, P and the point Q. This angle over there is 90 degree. So here we have the right angle triangle. Now one side of this right angle triangle is RQ, that is ultimately the diameter of the semicircle. Radius of the semicircle has been taken as a variable z. Therefore the length of the diameter would be equals to 2 times z. Okay. Now I will take the angle PQR as a variable equals to theta. Now in this right angle triangle, the value of cos of theta would be equals to base upon the hypotenuse. The length of base is PQ and the hypotenuse is having a length 2 times z. So in this right angle triangle, we have got the value of cos of theta. Now look carefully that the angle theta is the angle PQR. In this diagram, the angle PQR is present like this way, hence this angle would have a value theta. Now what we can say that is the angle theta is also present in the right angle triangle PMQ like this way. So in this right angle triangle, the value of the angle PQM is theta. Hence from the perspective of this right angle triangle, the value of cos of theta would be equals to base upon the hypotenuse. The length of base is x plus y and the hypotenuse is having a length PQ. So here we have got two equations and the left hand side of both of this equation is equal. Therefore by comparing these two equations, we will get PQ upon 2 times z is equals to x plus y upon PQ. By doing the cross multiplication, we will get pq square upon 2 times x plus y is equals to z. Okay. Now recall that in the beginning we have got the value of pq by applying the Pythagoras theorem in the triangle PMQ. So the value of pq is square root of x plus y the complete square plus y square, and here we have pq the complete square, therefore this thing squared, and because of this square root and this square got cancelled out. So what is finally remaining is x plus y the complete square plus y square divided by 2 times x plus y is equals to z. Now by separating the denominator on the left hand side, I will finally get x plus y upon 2 plus y square upon 2 times x plus y is equals to z. Now this equation is important because it is a relation between the radius of the quarter circles and the radius of the semicircle. X and y radius of the quarter circle, z is the radius of the semicircle. Now using this we will get the relation between their areas also. Now recall that we have taken the area of the bigger quarter circle as equals to a and radius of that quarter circle as equals to x. Therefore the value of a would be ultimately pi x square upon 4 because it is a quarter circle. And solving this will give us the value of x equals to 2 times square root of a upon pi. Okay. Similarly, we have taken the area of the smaller quarter circle as a variable b. Therefore b would be equals to pi. Radius of that we have taken as y, therefore pi y square upon 4. Solving this will give us the value of y equals to 2 times square root of b upon pi. Okay, so here we have got the value of y in terms of capital B. So now this value of x and this value of b we will put in this equation. So on the left hand side we have x plus y upon 2, therefore 2 times square root of a upon pi plus 2 times square root of b upon pi upon 2 plus y square upon 2 times x plus y. Therefore the value of y square would be equals to 4 times b upon pi divided by 2 times square root of a upon pi plus 2 times square root of b upon pi. Okay, and this thing is equals to z. Okay, now let us simplify the left hand side. Therefore we can see that 2 and 2 taken common cancel out with these 2. Over here we will take 2 common. 2 into 2 will become 4 and that will ultimately get cancelled out with this 4. So these were the terms that were cancelled out. Now we can see that from this and this we can take 1 upon square root of pi common. Therefore inside the bracket root a plus root b plus b upon pi upon. Now from this term also I can take 1 upon root pi common. So inside the bracket I will get root a plus root b. Now we can even simplify this thing. So it will finally look like b divided by square root of pi multiplied with square root of a plus square root of b, and this thing is equals to z. Now we can see that from this and this we can even take 1 upon square root of pi common. So finally this thing will turn out to be 1 upon square root of pi multiplied with all these things, and this is z, that is ultimately the radius of the semicircle. Now area of the semicircle, so area of the semicircle that we need to get would be equals to pi radius square, therefore radius we have taken as z, so pi z square upon 2. The value of z we have got it over here, so that would be equals to pi upon 2 multiplied with complete square. Now this square can be broken with this and this term separately because they are in multiplication. Now 1 upon root pi the complete square will simply turn out to be 1 upon pi, and this pi will cancel out with this one. So we finally get the area of the semicircle equals to 1 upon 2 multiplied with square root of a plus square root of b plus b upon square root of a plus square root of b, and this thing the complete square. So here we can see that we have completed the goal to get the area of the semicircle in terms of a and b, that is ultimately the area of the quarter circles. So this was my way to solve this particular question. If you have any other method other than this, do comment below, and if it's hard to comment, you can email me or else you can send it to me on my Instagram. The link is in the description.